Hello friends, this is day 6 of doing Codeforces until I become an specialist. Okay, and now we are doing 16th problem of CP sheet, which is given by TLU. So it's about desorting. So desorting. Come on, come on. Okay. Call an array A of length n sorted if a1 less than or equal to a2 less than. So it's just a sorted property, right? Now, so n Tarsis has an array A of length n. He is allowed to perform one type of operation on it. Choose an index I. Add 1 to A1 to AI. Okay, we can choose an index and we can add integers from 1 to that index which we are choosing. Okay, this is nice. And subtract 1 from um, I plus 1 index to the end of the index. I mean, end element of the array. Okay, it's I think I hope you understand it. The values of a can be negative after an operation. Okay, determine the minimum operations needed to make a not sorted. Okay, here the array is sorted. We just have to make that array into unsorted just by using the operation, and that operation is nothing but we have to find out the index, and after finding out the index we have to add 1 from 0 to that index value, and we have to subtract 1 from chosen index value plus 1 to the end of the end index of the array. So what if we are finding we are turn that into unsorted array, then we have to give the minimum number of operations needed to make the array not sorted. Okay, I actually didn't read how we are able to read the input because we already know. So here t represents the number of test cases, and this n represents like length of an array, and we have to read this array of elements. Okay, so and the intuition here is like so it's nothing. Uh, he mentioned that already. So we just have to give the minimum number of operations required to turn that into unsorted array. Here let us see 1 1. Here uh, array contains of length elements of uh, okay, elements, two elements, that is the array size is 2, and here the elements are same 1 1. So that means it is sorted. It is sorted. We have to make the unsorted, and we are choosing index 1. So from that we have to increase values. So then it goes to 1 1 plus 1 1, like that. So here the elements are 2 2, so which is even not sorted. So that's why we are choosing index 0, and we have to increment that only, and we have to decrement after that. So now it will become 0 and 2. I mean, sorry, yes, 2 and 0. So 2 and 0, which is unsorted. So 2 and 0 is unsorted, right? So then we just have to return one operation, because there is only one minimum operation required to turn that into an unsorted array. So 1, 8, 10, 13. So initially it is sorted. He mentioned that initially it is sorted. We just have to make so we have to perform the operation. But which index we have to choose? That is a big question here, right? So it's completely depending on the index which we are choosing. So if I choose the index 1, and like index 2, sorry, first index, which is nothing but 0, so I have to increment only that, and it will become 2. So is 2 is less than 8, so we have to increment that 0th index until that value is greater than the index plus 1th value. So now 9 greater than 8, so now it is 2. But we have to perform 9 times operation here. 9 times we are performing the operation, right? uh, yes, right. Because 8 minus 1, which is equal to 7. Sorry, 7 times we have to perform the operation. So which is more. And if you take these two elements like 8 and 10, so fine, 10 minus 8, which is equal to 3. So that it is nothing but this 8 is actually 3 times less than the 10. So like it have deficiency 3 to uh, equal with the 10 value, right. So we have to perform 3 times of operations on this, so then it will become uh, after it will become equal to the I plus 1th index, so that is 10 10. So but we have to make that into an unsorted, so we have to perform here another more operation there. So that means here 3 plus 1, which is equal to 4, we have to perform 4 types of operation, 4 times. The operation has to be performed here 4 times, but here if we are choosing 1 and 8, we have to perform 8 times of operation, because 8 minus 1, which is equal to 7. And so that means 1 plus 7 is actually equal to 8. 8 8 are actually sorted, so we have to make it unsorted. So if I have to choose only these zeroth index, then I have to perform I 8 minus 1 plus 1. I mean 8 minus 1 is actually 7, 7 plus 1, which is equal to 8. So I have to perform 8 times operation. Then it will going, this one will going to change into 9, and 9 is greater than 8. It is unsorted. So just remember that. So here we are performing the operation 9 times for zeroth index, and for eighth index, that means for first index, eighth value, that means first index, we have to perform the operation 10 minus 8 plus 1, which is equal to 4. We have to perform 4 times operation here. But here, third index, I mean second index, which is 10. So that 13 minus 10, 13 minus 10 here, 3. Yes, we have to perform 3 times operation, and then it will going to be 13. So 13 and 13 same, so plus 1 operation. Then 14, which is greater than 13, so unsorted. So right, so here we are getting the values like 7 4 4, but none of them are present actually equal to the 2, which is the answer of this second test case. So how actually to come here? uh, we should make this array into unsorted with just 2 operations. Oh, is it true? uh, then if you are adding 1 1 minus, so if we are choosing 8 and okay, I just forgot the main thing, right? So I only uh, like until now I only bother about the first condition of the given operation, nothing but from 1 to I we have to add 1. We have to do another operation here also for a single test case, which is from I plus 1th index to the end index of an array, we have to subtract minus 1. So for that, so for that, like this is 8 and this is 10, and this is 1 and this is 30. So imagine these are all the array inside an array, and this is index 0 and this is index 1, this is index 2 and this is index 3, right? So we have to perform the operation for up to 8, like we have to perform the add operation up to 8, so it will become 2. So if we are performing one time, operation has to be performed here one time. So after perform the operation, the result is here 1 and here 9, but from I plus 1th index it will going to decrease. So here 9 and here it will 12, and after perform the operation in second time, now the answer is 3 10 and here it is 8, and here it is 11. See here, observe this. So here 10 is not less than or equal to 8. So this is unsorted. So we just return these values. So minimum number of value we have to perform two times. Operation has to be performed two times here to make these sorted array into unsorted array. Okay. So it's really difficult to choose the index. So here have to choose index I index 1. So 8 minus 1, and here it value is equal to, oh here 8 minus 1, actually the value is equal to 7, and here the value is equal to 8 9. So 2. Oh, the difference between the 10 and 8 is actually 2. Okay. And here the difference is 3. So the difference is 2. So isn't that why the result is 2? So for 9 and 1 the difference is 8, and 9 and 14 the difference is actually 5. But we are getting answer here as 3. So when I actually don't have an idea. So let us take the test case 1, 9 and 14. Here, as I said, the difference between these two, 9 and 1 is 8, and 14 and 9 is actually 5. So the minimum difference is generated at the index 1. Okay, at the index 1 here, the minimum difference is actually we have to find the difference. So after writing the for loop, we have to iterate from the from 1 to the end of the array. So here it is 2, unfortunately. And every time we have to check array of I to the array of I minus 1. So here 9 minus 1, which is 8 difference, and when incremented 14 minus 9, which is equal to 5 difference. So as 5 is the difference, now the index where we are starting actually equal to I minus 1. So here 1 is the index. Okay, good. Uh, so the answer is not actually 3. We have to perform the operation 3 times to make this array into unsorted. So how it actually 3 times? Uh, it will, but we have to get a 3 from these 5. How? 5 to 10, 10 divided. Oh no, no, 5 divided by 2. So 2 plus 1. 2 here, the 2 is 4. So 2 plus 1 actually 3. Okay, it works. And is there any other possibility? 5 to 10. So 10 and 10 to get. Yes, we have to perform the addition or subtraction, which is common for all. Okay. We wonder if this is applied for the other test case. We already seen here. So we find these 10 minus 8, which is 2. So 2 by 2 plus 1. The answer is 1 plus 1, 2 again. Wow. Then 1, 3, 2. So the difference here 2, and here the difference is 1. So difference is 1. So 1 divided by 2 plus 1. 1 divided by 2 plus 1. So which is equal to 2. So we should have to perform 2 times. No, 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 not at all. Why? Guess why? Because this 1, 3, 2 is already sorted. So we just have to return 0. Okay. Okay, we should aware of these test case, right? We should aware. And so let's just read uh, this. In first test case, we can perform one operation to make the array not sorted and the array A to become which is not sorted. And when I is equal to 3, uh, we're just explaining what we have been through up to now. Let's code it. So code chef, C++, compiler, open it, and so on to the code. So while up to these test cases, we have to read n represents this size of the array. Here I'm taking vector, which is integer data type, which whose name is a and whose size is n, and we have to fill elements into this vector I less than n, I plus plus. So we have to take, so for that we have to use a scene and exactly at that particular index only. Okay, cool. Hmm, yeah. So first we have to check whether the array is in sorted order or not. So for that we have to iterate this from 1 and here store that it's duplicate value which is array of 0. So the first element, right? So if only if array of that particular index is actually less than d, that means here array of 0, right? Right or wrong? It is right. So sorry, it's just code. This for loop actually just checks whether the array is sorted or not, right? I think you already know. So what should we do? Uh, like we should print 0, print 0. Okay, and we should go to the other test case. No, we should break. Okay, and put here the variable j equal to 0, and here the value of j has to be changed, right? Then so when we use if j equal to not equal to 0, then only after break it will actually come out. We should continue. We should have to go to the other testicles. So if a of I is actually not less than, it is not actually less than a of 0. Like a of 1 is actually not less than a of 0. A of 0 is actually less than or equal to a of I. So we are writing the opposite test case. So if it is right, then D going to be A of I. So then only we are checking the consecutive elements are in order or not, isn't it? So we have to continue. So if it is not, what should we do? What should we do? We should find the difference between these, and which has the minimum difference? We have to add plus 1 to it after dividing by 0. That's what we do, right? So yeah, we are running a loop. We have to run it again, but this time it has uh, to solve the other test cases. Is right? So from one, so we have to take the difference. Like here, minimum difference. It's actually equal to in max at we have to take only minimum difference. So minimum difference equal to minimum of this minimum difference and the difference which the difference for the current value to its previous value. So it's nothing but array of this current value to the array of that previous value, right? Okay. Why I'm writing why I have to take D here? It's not necessary to take the previous A of 0 into this D value and compare that D here. So it's not necessary. We just use here whether A of I is actually less than A of I minus 1. Uh, Boom. We should get out of the loop and we have to print 0 because there is no need to perform the operation, right? Okay, so whatever, it is also right. There is no need to change the code. And here we have minimum. After iterating throughout the array, this for loop gives the minimum difference. Okay, right? So now we just have to print minimum difference by 2 and plus 1, right? This is what we have to print, right? So minimum difference by 2 plus 1. 2 plus 1. So let's run this code on the given test cases. The output has to be 1203. 1203, right? So let's submit this. Don't we have a copy option? We're not eligible to submit because we have to register into the account. Remember me for a month. For this time, it will work. We have to submit. There's still some part exists, isn't it? Okay. Oh, we have to return 0. Yeah. After completion of this for loop. What for loop? Yeah, so it's in queue. Okay, it's accepted. Good. It's solved. Now let's go to the forbidden integers. Forbidden integers. You are given an integer n which you want to obtain. You have an unlimited supply of every integer from 1 to k except integer x. Okay, integer x don't allow. Okay, but remaining all integers from 1 to k they are allowed. You are allowed to take an arbitrary amount of these operations we can make the sum of these operations equal to n. Okay, we have to take the integers from 1 to k, right? And among them, we don't allow to take the value x, and we have to check whether should we make the number n from these 1 to k elements except s. If it is, we have to print s. If it is not, we have to print no. Oh, it is quite simple then I thought. So 10, 3, 2. Oh, for this test case, the output is s. Oh, what is this number? For each test case, if in the first line we have to print s and know whether you can take the arbitrary amount of each integer from 1 to k. Okay, good. Except integer k. Okay, okay. If you can, the second line should contain the single integer m. It contains the single integer m. Okay. The total number of taken elements. Okay. Like the length of an array. The third line should contain m integers, each of them from 1 to k, not equal to x. The sum has to be okay. Okay, I got it. So like 10, 3, and 2. So for this 10, 3, and 2, oh yes, we can able to make the value 10 from 1 to 3 integers, but without taking two value, right? If there are multiple answers, print any one of them. Okay, okay. So he directly gave us, uh, you just need to find a pattern from the given test cases and use that pattern only to code. Even if when you execute that code, even the output of for these test cases is not match with these test cases, if your pattern is right, so definitely it will work. That line, I mean this line actually mentioned this whole part, right? Okay, so it's time to find the pattern from the given test cases. So how can we do that? So 10, 3, and 2. So like yeah, on this 10 is actually the number n, and this 3 is actually the number k. Okay, k, and this 2 is actually the number x, which we are not allowed to take, right? So let's open the paint. Okay, now so we have integers like 10 and 3 and 2. Okay, good. Okay, we are not these actually represents 1 to uh, 3 integers up, from 1 to 3 integers are allowed to use to make the sum 10. This is actually n, and this is actually the k, and this k, this is actually x, which is not this 2 is actually inside this range. So here we are not allowed to use 2, but we will make a integer uh, 10 with these 1 and 3 values, like 3 plus 3 plus 3 plus 1, which is equal to 10, right? Otherwise 1 plus 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 1, up to like 10 times. So the result has to be 10, 10. There are two ways here, but we should only print either of them, either one of them. Like it's hard for us to know how many threes are exactly we should have to use, but if the if one contains in the given range, because the range has to be started from 1. If one contains, we should easily make the n value, right? If one contains, we should easily make the n value. Yeah. Even it is odd or even, we should easily make that n value with the help of 1. So okay, but if this one is not allowed, what should we do? If one is not allowed, okay, okay, like here. instead of 2, if I'm saying this value is 1 here, so this now this 1 is not allowed, but here 2 is allowed. So 2 is allowed. So is it possible to make value 10 with this 2 and 3? So we shall have to check. So 2 plus 2 plus 2 plus and 2 plus and 2, which is equal to, oh, I'm sorry. So there is no need to take 6 twos. It's enough to take 5 twos. So we get 10. So as it is possible, bro. So we have to return right answer. Okay. And what if he say only 1? So the value uh, which you have to take the k value is 1. We have to take the numbers from 1 to 1. So which is nothing but 1. If the x value is also 1, we are not allowed to take any value, right? So in that time, okay, this operation, uh, we are not actually achieving the value 10 after combine by the combination of k, because there is no k value there, right? Okay, so this is one of the test case among them. And another one, I can find the value of n. So if the n value is odd, and what if the n value is even? So if the n value is even, okay, and if it is even and the x value is actually not 1, if x value is 1, if it is n, or if it is odd, if n is odd or n is even, if n is even, we should take them, and we should only print s, and after print s we have to input their size also. So for that, okay, so n and here x value is some x value which is not 1. So if it is odd and x value is not equal to 1, so we should check here for odd dash space. X value is not equal to 1, not equal to 1. Then what should we do? Oh, we should print s, and we have to run loop from 1 to how many times? Up to 10 times here. So we just have to add that x value, like 1 value to its 1, and we have to print that same. I think you understand. The array contains only one value, because 1 is not uh, excluded, because x is not equal to 1. What if x is equal to 1? Then sure, we are not achieving this. We have to print no. And for even test case, if x is even 1 or x is not even 1, we should actually achieve this. You don't believe me? Like if I take the value 8, if I say 8 is my n value, and if 1 is not included, and the ranges are from 2, so 1 to 2, so 1 is not included, we can make 8 by 2, isn't it? So if it is even 3, we can make this 8 with 2 if 1 is not even present. But if 1 is there, we should use the same logic which is used by the odd. But if 1 is not there, we should if there is any even, so okay, even there, so we should print that number of even times, like 8 by 2. 8 by 2, we should get 4. So we have to run the loop 4 times in order to print the values inside the array which are going to make the value n is equal to 8. And here, up to from, we are discussing 3 test cases. So 6, 1, 1. We are making if 1, 1 is exist. Oh, okay. We are not even allowed to take the value 1, and the k values are up to 1 only. So we have to print no here. And for 7, 7, 3. So as in 773, 1 is there. 1 is there. And we shouldn't as you don't believe me. So 7 is the value. We are allowed to take the values from 1 to 7 except 3. But when I say the n value here is 7, n value is also 7. But n value is odd. Whenever the n value is odd, so 1 is present. If 1 is present, we have to print 7 ones. That's enough. And we have to print the array size is 7 mark. Okay, it's accepted because uh, that is what we are followed as a pattern, right? Okay, and for these 4 to 1, 4 to 1. So here 1 is not allowed, but 2 is allowed. So with the help as 4 is even, you can easily make that. Okay, and yes, this is about the test cases. Let's code it out. So up to we have to take three values here. One is n, another one is k, and another one is x. K, x. So after taking the values, what is our first test case? If k equal to 1 and x equal to 1, what should we do? See out. No, yes, no, and continue. Okay. And what if it is not? K is actually not equal to 1 and x is also not equal to 1. Then we should check if n is even or n is odd. If n is even, uh, we should print if there are two ways for n is equal to even. Even if even if it is odd or even it is even, we should able to do that, right? So so if n is an even number, and we have to check if x not equal to 1. If x not equal to 1 and n is even, we have to print first we have to print s, and then we have to write a for loop as 1 is not equal to like x is not equal to 1 uh, up to a number of times. We have to print value I and not I. We have to print value x, right? With some spaces. Okay, cool. After that, we have to give in lines, right? So this is enough. But if x is actually 1, x is actually equal to 1, actually equal to 1, and that means 2 is there. Yes, 2 is there, or more than 2 values there, but it is done with 2. There is no need to go beyond that because it is even number, right? After all, it's an even number. So up to less than n, yeah, 2 less than n, simply no, n by 2, up to less than n by 2. We have to print what value? Value 2, 2 value, right? So like let me say here 8 is there and here 8 by 2 which is actually 8 by 2 which is actually equal to 4. So 0, less than 4. So 2 is printed. And 1 less than 4. 2 is again printed. 2 less than 4. Uh, 0. It is a 2 is again printed. 3 less than 4. Again printed. 4 less than 4. False. So total on console we have 4 twos are there. So 4 twos, which is nothing but 8, which matches. So enough. This is enough. So after that we have to print NLN. Enough. So but if what if that n is an odd number? Here also, if x is not equal to 1, we should uh, we should print that number value. If x is uh, not an odd, I just have some issue here. What is it? Imagine here the value n equal to 9, and here 1 is not allowed at x, so which is equal to 1, and we have values like 3. So here, so as k is equal to 3 and x is equal to 1, that means 1 not allowed it. So 2, 3 are enough. You are allowed to use only 2 and 3 numbers to make the number n is equal to 9. Number 9. So 2 plus, it's not possible to make with the 2, right? Definitely. So 2 plus 2 plus 2, which is equal to 8. But so 2 plus 2 plus 2 plus 2. So 4 twos. So uh, which is equal to 10. So this is less than 8 and this is less than 9 actually, and this is greater than 9 actually. So with completely 2, you are not able to do this. If even completely 3, yes, we should do, because uh, 3 plus 3 plus 3 actually 9. Okay, sometimes here 3 is not allotted, he say, and that means 1 is allotted. So we simply use 1. What if here 2? Only 2. We shouldn't able to do this, right? Uh, if I say here 4, so here 4 is also allotted. 4 is also allotted. So 2, 3, 4. If we have 3, an odd number, if you add an odd number to the odd number, we can get an even number. So with the odd number, should we get the every uh, odd number? Like, how can I say? By adding a value, by adding a value, by adding an odd value to its odd value, should we get an odd value? No, we should get an even value. Like, so odd value is 1, and another odd value is again 1. So we can get a even value, which is 2. Yeah, and it is applied for every test case. So which is 4, and here 3 and 5, which is 8. So sum of two odds is an actually even, right? Sum of two odds is actually an even, and when n is not odd, n is even. If n is odd, if 1 is not x is not equal to 1, that means x allotted, which is for x's, and if x is not allotted, then we should print, we have to check if n is 9, which is odd, and x is actually equal to 1, so 1 is not allowed to take. And so as we already written, if x is equal to 1 and k is equal to 1, we should go. So the minimum possibility of k in order to not satisfy that first test case, which is x is equal to 1 and k is equal to 1, is k is equal to 2. So that means we are allowed to use 2. So yes, okay. So and this is an odd number which even you can't make by adding two even numbers. So here, whenever the x is equal to 1, the value has to be greater than 2, not even 2, greater than 2. So that is 3, right? So that's what we should write here. If k is greater than 2 only, there is a possibility to print a s. Otherwise, we should print no. Yes, we should print no. Otherwise. So if k is greater than 3, so that means 3 is exist. Odd number is exist. Is it possible to get any odd number? So if 5 is an odd number, but you shouldn't get that odd number with the 3. Right? Okay. If k is equal to 1, it will take it. If k is not equal to 1 and it's greater than 2 and k is greater than 1. So 2. If k is equal to 2, wait, uh, I'm stuck here. If k is equal to 2, here, if k is greater than 2, so k is greater than 2, that means here k is equal to, k has to start from 3. So for n is equal to odd number, the minimum odd number is 5. Let me say it is 5. Uh, and here x is actually equal to 1. So 1 is not allowed to take. And here k value, it is greater than 1. So how can you make the value 5 with 2 and 3, 2 plus 3, 5. And 1 plus 1 plus 1 plus 1 plus 1 is exist, it will take care of it. And 2 and 3, 5. 1 is not used, 2 and 3, 5. Okay. Okay. Something that strikes me here. So let's dive into that striking point. If I say the value n is equal to odd number, which is 9, let me say just a 7. How can you get 7 if x is equal to 1? That means x not allowed to take. And so possibilities of values. Uh, if we can get 7 just by 2 plus 2 plus 2 plus 2, 8, 2 plus 2, 4, 4 plus 4, 8. So here, which is we can get greater if we add 4 twos. So if you add 3 twos, we can get 6. And as we are not able to use 1, so we are stuck here. So, but if we have allowed to take value 3, so 2 plus 3, 2 plus 3, which is actually 5. So 5 plus 2, so 7. Okay, so it is possible to get 7 in the same way as we get 5. So if n is odd, we should print. So how many twos exactly we have to use here? For 5, I'm using 1 2, and for 7, second odd number, I'm using 2 twos. Um, is there any way to say that this 7 has only uses 2 twos? So 7 by 2, which is actually equal to 2 threes is 6. So we are actually using 2 threes. So 7 into 2 by 5 by 2, which is actually 2 twos of 4. So we are actually using 2 twos here. 2 twos here, but we are using only 1 2, right? And here 7. So 3 twos here, but we are actually using 2 twos to place. I'm getting it. Like if the value is 9, which is an odd, which is and it has divided with uh, like, okay, so the number is here 9. Now n is equal to 9 and x is equal to 1, and here now the k value is greater than x, so it may be 2 or it may be 3, it may be 4. Let us take it is 3. So we can get 9 by adding how many twos? So for that, I'm saying we just have to divide that 9 with the 2. So we get 2 fours are 8. So here 1. This is how decisions pop up. And we are getting 4. So 4 minus 1 number of 4 twos we have to use. Along with we have to print 3. It will give us 9. Yes, I'm saying that. 4 minus 1, that means 3. We have to use how many twos? 3 twos. So 2 plus 2 plus 2 plus 3. So here the total is 6. 6 plus 3, 9. Yes, it works. So um, if is greater than 1, okay, value is always greater than 1, right? Then what touch case we should use? Greater than 2. What should we print? First we have to know how many twos we have to use for that. So the number is how many twos we have to use. Let me say it is TT. How many twos we have to use for to build n, and we have to just divide that n with 2 and store that in TT variable. So and we have to write a for loop in order to print that number of twos. So which is so int I is equal to 0 and I has to be less than TT. So I has to be less than TT. So we have to print less than TT minus 1 time and I plus plus. So there may be a confusion. Even maybe you can get it. So in order to clear, I'm using this. Okay. So here iteration starts from 1. So 1. So let I say TT is actually here. TT is actually 4. So from 1 less than 4, 1 less than 4 minus 1, 3. So and 2 less than 4, 3. 1 less than 2 less than 3 less than 3. So we have to print 3 twos here, right? So that's what here happening exactly here. Yes. So we have to print uh, 2 value here, 2 value here. Uh, in the end, we have to print 3 value, and after that, and slash n. I think this is enough. If n value is not greater than 2, it it is exactly 2. Even then, we shouldn't able to get the value. Let's check the code. Okay, successfully. As oh, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 twos, 20 here value. Why? What should exactly this code performs? Yeah, n is actually even. Okay, n by 2. So even, and k not equal to 1. K not equal to 1 means this is how we have to k not equal to 1. Okay, we have to print we have if k is not equal to 1, we have to use that 1 value here. Right, right. So, but before that, we have to print their size, their size. So, how can we get their size? Here I'm using one in order to print five eyes. So one is not applicable. So here two one x is not equal to one. We have to print one in 10 times. So the size has to be n. So which is here same. So s after that s statement we have we have to print their size. The size is actually equal to n value. It, the same line is goes for mm, here. The size has to be reduced by n by 2 whenever so like whenever one is x is equal to 1, so 2 is there. So if 2 is there and the value is 10, 10 by 2, which is equal to 5. So 10 by 2 shall be 5. So the size is 5. So here we have to print 5 i's s. So for odd, how can we get the size? This is same. We have to print n size is n as we are using one. And here it's typical to say like not definitely one. And let's see the paint what we are getting here. So n is actually 9, and the size here is 1, 2, 3, 4. The size is 4. That means uh, yeah, we are getting some value here. So 9 divided by 2. That is our size. I'm saying that 9 divided by 2. 9 divided by 2. The size is 4 because we have to print 3 twos and 1. Okay, let me submit this and check whether it satisfy all test cases or not. Okay, S so 10 and 3, 4, 5, 6, 10, and this is no. Second test case is no. Second test case is no. Third test case is S again. S again, and which is actually 2 and 2, 2. 2, 2. Fourth test case is actually again 1, and fourth test case is actually again S, and the size is 7. Wait, fourth test case here for this 773. Oh, come on, we have to get an 7. Simply 773. It fails. And last one is the size is 7. Yeah. Why this 3 actually? Here, x is not equal to. Yeah, I made a mistake here. So we have to add a 1, not this. Right? Now it will give 1 over there instead of. It's not like we are not able to get 7 and the size is 1. For that, we just have to check whether the k is actually greater than like k is actually if k is actually equal to 7 and uh, if it is not equal to n, we have to print that the k value 2, 3, 4, 5, 6, 7. So let's try to submit it and let's find whether it is working or not. So okay. Uh, It's already item. How to figure everything. Recue. Running on test case one. Ah, I don't actually feel anything. If it is submitted, I'm happy. If it is not submitted, I'm going to learn something new today. Wrong on test case one. Why? Go fast. It is wrong on test case one. S for no. S no. S no. SS no. S no. S 8. S no. SS no. S no. SS no. I'm missing to print S here. Wow. Come on, Arjun. You shouldn't do this. I don't know whether it is right or not. But we just have to print S first. S no. It's just the same as before. What? For this. Thinking. S no. Okay, for two. For this one, you have to print S. So what is this test case? One, two, three. For third test case. So which is 4, 2, 1. So when n is n is even and actual equal to 1. So here we are missing here also. Uh, First we have to print S and then we have to print size only, right? So S and then size and S and then size. Here directly no, indirectly no. Let's check this. S no, S no. Nice. So totally we are adding two S's. Come on, you have to be fast. We're gonna have to copy this all. So code goes from here to there. Okay. Wait, wait. Okay. Hey. Okay. See, let us see. Running on test case 6. Running on test case 12. Uh, I understand. It, it's going to give me to why? I'm just using bunch of conditional statements and if statements. If statements is necessary, right? Oh, what is this? Come on, Jude. Come on. Come on. Come on, mommy. Accepted. See, this is how we can solve this problem. And I know there are a lot of approaches other than this, but it's simple. It is simple because we are actually writing the code from the given testing cases. That's what actually CP lies on for the beginners, like for newbies like me. And okay, we will do this sum from tomorrow. And thank you guys for watching this video.